In this video, we are going to build a real-time modern data stack pipeline for banking. Not a toy setup, but enterprise-grade project that is closely identical to real world. If you're trying to build a data engineering portfolio and you're looking for a project that really grabs attention, this is it. We're talking about using Postgres as our main database, Kafka plus Debezium streaming changes in real time, data lake storing all the data, DBT transforming our data into star schema and SCD2 inside Snowflake, and Power BI turning the data into dashboards. On top of that, we will be implementing cicd in Git Actions and DevOps for automation and Airflow orchestration. And that is a real deal. By the end of this video, you'll know how to put together a project that doesn't just add to your portfolio, but it proves you can build a real-world enterprise-grade system. Like I said, this is not just another demo project. This is the work that puts you ahead of the competition. And with that being said, if you like the content, don't forget to follow. Let's begin. Before stepping into the process, let's have an abstract of what we're going to do. This is the data pipeline, which is basically a plan that we're going to follow to complete this project. Like any other data pipeline, our data pipeline also starts with a data source. And in this case, in our project, we will be using a database. Unlike the last project we deal with, the stocks project, we used an API to get the stock data, the real-time stock data. But unfortunately, for banking, we don't have any API that offers that feature. Because of obvious security reasons, anyone cannot publish bank transactional data. So that's why we will be generating this data using a generator code, and that data will be stored in the database, which will be our SQL database, a relational database management system, or DBMS, right here, like I mentioned. And there is a reason for me using SQL instead of NoSQL database. And that is primarily because this is a project on banking. It should be focused more on security and the structure that we store the data with, which pretty much a best match for an SQL database rather than NoSQL, which doesn't have any structure whatsoever. So that's why we are using an SQL database. And also, SQL database also offers ACID features, which stands for atomicity, consistency, isolation, and durability. If you want to know more about it, just go online and type in ACID features for SQL database, and you will know more about it. There are like features that are offered by SQL database, and that's why we're using SQL database here, which will be a Postgres server. We will talk about it later, and yeah, that data will be pulled out and streamed using Kafka plus Debezium. Well, we are using Debezium as well in this project because Debezium offers CDC, change data capture. It is a best fit for an SQL server. It captures any changes that happens in the database, whether it can be update, insert, or delete. All those changes will be captured using using Debezium from the database and will be streamed with Kafka as a streaming engine. And that's a data streaming step. We came through database, and we came through data streaming, and then this data will be pulled out and be stored in S3 bucket, which will be min.io. We will be using min.io as our S3 bucket because I don't have access to AWS S3 or Azure storage account right now. So I am using an open source storage space, which is min.io. We'll be using that to store the data, which will be the raw data. Well, this structured data that is in the SQL server will be taken out as a JSON string. That JSON string will be stored in this bucket, and this data will later be pulled out and be stored in a bronze tier table in Snowflake. And this process of pulling data out of S3 bucket and storing that into Snowflake bronze tier table will be handled by Apache Airflow, which so we use Airflow to orchestrate this process. And from there, it will be the raw data will be cleaned and stored in silver tier table, and then it will be transformed and make the data business ready, and this business ready data will be stored in gold tier table later on, which is our end of the data transformation data processing step. This whole data processing step is handled by DBT, which stands for database transform. We'll be using DBT for data processing and SQL as a data warehouse. Here's the thing. This project includes an OLTP and also OLAP. In case if you don't know, OLTP stands for Online Transaction Processing, which is our database. So this database handles all the transactional stuff. But OLAP, which stands for Online Analytics Processing, is our Snowflake. So Snowflake is a data storage space which handles the analytics part, and OLTP is online transaction processing is our storage space which handles the transactional processes. That is that. I just want to put that theory in, so if you're a beginner, you will be clear about what we are dealing with. Okay, now the transformation is done, and the business ready transformed data is in Snowflake now. This Snowflake, the data in the Snowflake will be taken out and connected to Power BI using direct query method, not import, just like the last project. If you don't know the difference between direct query and import is just a static entity. So the data will be taken out and downloaded into Power BI separately. It doesn't persist the connection between the source, which is our Snowflake, and Power BI. There will be no connection after we import the data. But if we use direct query method while we connect Power BI to Snowflake, this data will be dynamic. If the data in Snowflake changes, the data in Power BI also changes parallelly. So we are going to use direct query because this project is real-time project. So that is why we're using it. And with that, the pipeline will be finished. And there is one more thing I have to mention. We will be using Docker to create containers for all the tools that we're going to use for Kafka, Debezium, and Airflow. Well, Snowflake is a web provider, so we're going to use Snowflake outside of Docker. And then after finishing the whole project, we will be using no wait I forgot to mention, we will be using SCD2, slowly changing dimensions, which is a best practice uh, to implement in real-time projects. We'll be using slowly changing dimensions, which means if the data, if a record in a table changes, let's say there is a customer table which has the customer ID and there is email. If the customer wants to change his email anytime in the future, if he changes, the old record that has the old email ID will not be deleted or replaced. It will also be in the data. It will also be in the data warehouse, but the status of that particular record, the old record, will be turned to false, which means it will basically turn its status into active, but the new record status will be, I think I messed it up. The old record, the old record status will be inactive and the new record status will be active. So we will be tracking the history as well parallelly. So we will be implementing SCD2 and also star schema. In case if you haven't understand any of these terms, we will be working with that. So you will definitely understand by the end of this project, right? And then after getting all the data pipeline working, We will be implementing CI/CD, continuous integration and continuous deployment, using Git Actions. So whenever a new change is occurred to any of the code or any of the file, CI will be CI will be executed. So it checks the quality and also checks if there is any errors, and it does some tests with the code that is coming in, and then it will be deployed using CD, which automates the integration and deployment step. So we'll also be including CI/CD in this project using Git Actions and DevOps as well. So that is the whole pipeline that we are going to follow in this project. So firstly, to start with, we need to initialize the Docker containers first. Well, if you don't know how to install it, you can just go to any web browser and click Docker download. Head to their official page. Here, if you have your processor is Intel, go for the ARM64. If it is AMD processor like mine, you can download the AMD 64 one and download it, install it with all the default settings it has, and also download VS Code. That helps a lot for us in this project. This one right here. Yeah, download this one and install it as well. We'll be using VS Code, Docker, and I think that's it. Yeah, that's it. And the rest of the other tools we'll be installing using commands on PowerShell. So these are all the applications that you need to install on your PC. These two, and yeah. Going further, we need to first create all the containers inside the Docker. So let me open the Docker first. You don't necessarily have to sign in or log in to Docker. Well, if you want to, you can, but I haven't signed in. Let me minimize that. Before creating the Docker containers, there is one more important thing that we need to do. We need to create a local repository for our project. So let's do that. For that, let me open PowerShell. You can also use command prompt instead. Okay. And here, I'm going to create dir banking. Enter. So this is basically how I created a repository, and it will be saved in C drive, users, and your username. Mine is J, and there you go, this one. So we basically created a folder named banking modern data stack. And here, let me just create a few more folders inside. To create the folders inside this repository, we need to enter this command. Say cd, which stands for change directory, and click our folder name. So now we are inside this folder. Now we can, whatever folders we create here will be displayed here inside our repository. And mkdir stands for make directory. It's just a command to create folders or files. No, just the folders, not files. Sorry. So make directory. Now Let me just say the folder names. A folder for Docker, one for Postgres, which is our SQL server, one for data generator, dot GitHub slash s. Enter. There you go. So now we created 6 folders, one for Postgres, which is our SQL server, and one for landing. Let me just rename this. Let me just rename this as consumer, just to make it clear to understand. So this is our consumer folder, and a Kafka Debezium folder, a folder for Docker, data generator, and .github. Inside the .github, there is workflows. This is where we do the CI/CD processes. This is the folder name. This should be the folder name to let the GitHub know where the CI/CD is executed. This should be the folder name. Okay. Now we have the folder names. Let me just go ahead and do NI. NI stands for new item. README file. README.mb. I just created a README file for GitHub. So for the next process, let me just copy paste this and create git ignore. Paste it. Let me include docker compose.yml file. And one more file. I think that's it. So here we created a docker compose YML file. This is the file that we use to configure the containers inside the Docker. And then we use Docker file Airflow to run the Airflow server and Yeah, I will talk about it later. And this is a README file. It's just a static README file that we can use in GitHub. There's nothing with this. Uh, there's nothing to do with this in this project, but at the end, we can just make a README file that we can show in the GitHub, just like this one. If you don't know, let me show you an example. Let's take our last project, which is the real-time stocks MDS. So this is where whatever we do inside the README file will be displayed here in the main page of our repository, GitHub repository. And that's why we created a README file. Okay, now let me just run. So if you are already installed VS Code on your PC, when you type in code dot, wait, I think it is code space dot, the VS Code automatically opens, and it will open in our repository that we just created, banking modern data stack. And here, firstly, like I said, we need to configure the Docker Compose file. For the Docker Compose file, I already have a file with me. Let me just copy paste it. Copy and paste it here. So this is the compose file that we're going to use. This file, we're basically doing creating a zookeeper, which is a requirement to run Kafka. We need zookeeper for that, and this is the main Kafka container. And then we create connect for the CDC because we are going to use Debezium. So we're going to use Debezium connect. And then this is our database, SQL database, Postgres container. And this is our storage space, which I talked before, S3 bucket. Like I said, we are going to use min.io for that. And then Airflow web server. This is the UI, the Airflow UI, and this is the scheduler for Airflow. And this is dedicated Postgres for Airflow. We basically we define the ports while we create. These are the ports that we use to connect and retrieve the data or push the data into. So these are the ports that we need to use when we do that. So, yeah, that is pretty much it. And these are the volumes that we're going to create in our PC, in our local PC for the operations. And I'll tell you why we create them later. So I think I spelled it wrong. It should be all small. Here, for the Airflow, we used another file called Dockerfile Airflow, which is a Docker file. We used it because at one point of our project, we will be also automating the DBT run process by using this one. Let me open that as well. Right here. This will be our Docker Airflow Docker file. This basically installs DBT Snowflake and DBT core using pip install. That's it. We need to install that inside the Airflow container. So that's why we used user as Airflow and from Airflow. So we are going to install DBT core and DBT Snowflake inside Airflow because we're going to run the DBT inside Snowflake inside Airflow to orchestrate it. That's why we need this file as well. Did I copy it? I think I did not copy it. We have to copy that file. Just copy this. By the way, all the codes and files I used in this project will be given to you in the GitHub, and the GitHub link will be in the description. Okay, let me just open the file that we created and paste it here. Now save it, Control S. Save the Docker file as well. And now there's one more thing that we need to do, which is our .env file. Let me just create a new file. No. New text file. And copy everything inside and paste it here. And save it. In our repository. Should be users J right here. Name it .env. The file should be I'm not sure which one to choose. Let me just save it using Notepad. So we don't need to specify which file it should be. Let me just save it from here inside our repository. Name it .env and save as type should be all. Encoding should be UTF-8. This will create a .env file. It is right here. Let me just close this. Don't save the file that we created. You might be wondering why we created a separate file that has all these credentials. So these are the credentials that we're going to use for Airflow, MinIO, and Postgres. Because we will be uploading this compose file into GitHub, yes? So when we upload this file into GitHub, GitHub won't allow us to upload a file that has any credentials or any secrets or any valuable information in it. It won't allow sometimes, and also even if it allows, it is not a best practice to save your secrets inside a repository inside GitHub. So we need to, we should not hard code our credentials inside the code. Instead, we need to create a .env file where we can store all our credentials. This is the Postgres username, password, database name, MinIO username, MinIO password, Airflow user, Airflow password, Airflow DB name. So separately in a .env file, and this .env file will not be pushed into GitHub. All right, so this will be in our local PC or in our local repository. And only the Docker compose file will be pushed into GitHub, which doesn't have any credentials hard coded. And that's why we are doing that. If you take a look at, let's say, Postgres, right? Postgres right here. So if you hard code your credentials, you will be typing in your password in this part and your username in this part and the database name here. And we did not do that. We are referring to .env file to take Postgres password right here. Postgres password into this part and Postgres user into this and Postgres database into this part. We are calling those actual values using this file. And we're not hard coding it. It is a best practice to hide your secrets from a public repository. Same way as in MinIO. here as well. We're not hard coding them, we're calling them using .env file. And the same thing for Airflow as well, right here, the same thing. So that's why we use a separate .env file to store all the passwords or all the credentials. Maybe the right term to use is the secrets that you don't want anyone to know. So you can store them in .env file. And that's what we're doing here. Now, let me just save all these 3 files. And now let's run our compose file and create those containers in Docker. To do that, go here, Windows PowerShell, open my repository, banking, modern data stack. And here, the command should be docker compose file, docker compose dot yml up st. So we're basically saying compose, we're basically saying docker compose with the file docker compose.yml that we just created, and saying up. Up means it creates the containers. If you replace this down and run that again, it deletes the created containers. Okay, now if you see this page, it says containers, all the container name, it lists all the container name, it says started, then you should be able to see all those containers listed inside the Docker desktop. And to confirm everything is working fine, you have to click on the ports next to the min.io. There should be a UI for that. When you click on the port, you're supposed to land on this page, and the credentials for this page are min.io admin. Copy paste it in both the columns, login, and then you'll be dropped in this page. And same for the Airflow web server. Click on the port right next to the Airflow web server, and you will be directed to this page. And try login with these credentials. No, sorry. These credentials are not supposed to be the Airflow web server credentials. These are for the Airflow DB. So we haven't initialized any credentials for Airflow web server. So we have to initialize them first. To do that, we have to type in docker compose again, exec execute. Like I said, Airflow web server, and say Airflow users create, say username as J, first name, let that be J as well, and last name, just say K, and role admin, email. You can use any email, any random email. That is not supposed to be working as well. You can just click a random email because these are personal project, it doesn't matter at all. So I'm going to say temp@gmail.com. And for the password, say password 123. It says J already exists, but you should be seeing the account J is created. You should be seeing as a different prompt here. But because I already created this in this Airflow server, it says it is already existed. Okay, now let's try those credentials here. Username J and password is password 123. Sign in. So you'll drop in this page. This is the home page for Airflow. Well, that confirms both of them are working. Now we initialize the containers. Now let's head to creating the database. For that, I forgot to tell you when I mentioned those tools, not just Docker Desktop and VS Code. We also need dbeaver. I forgot to say you that. We also need to install dbeaver on your PC. Let's say dbeaver download. This is where we can run PostgreSQL commands, queries. Here, you can just click on Windows installer and install with default settings. And then open dbeaver on your PC. And you'll land on this home page. Now we need to connect our Postgres server that we created inside the Docker right here, this one, to dbeaver. For that, on the left pane, click on the three dots right here, view menu, and here click on new database connection. Select PostgreSQL. Next. The port number should match exactly to the port that we defined, which is right here, Postgres, this, and this one is the Postgres server port 5432. It is already 5432, so I don't need to worry about that. Now here for the username that we specified is Postgres for both username and password. So let me paste it. Now click on test connection. It says Asia, time zone Asia, Kolkata. I got this error already. Let me just fix it real quick. Users J app data. In case you don't find this file, you have to click on the view and show, enable hidden items. Then you will find app data as well right here. Click on app data, local. Now, should be, let me see. Local dbeaver configuration, this one, and here you need to, if in case you got the same error that I got, you have to do this, or else you don't have to deal with this thing. Okay, so in case you got the time zone error, you have to head to this file, open it, and edit that file, and at the end write this. Say user time zone equals, well, I'm in Asia slash, this should be your time zone where you are operating your host machine from. In my case, it is Asia, Kolkata. So I'm going to choose that as my time zone. Now save it. Test connection again. Let me just redo that. PostgreSQL, copy, paste, localhost 5432, test connection. I think I just need to restart the whole application. So let me just do that. Close this totally and open that again. dbeaver. Click on the three dots again. New database connection, PostgreSQL. Fill in the details. And now let's click test connection again. There it goes. Now it is connected. You may not face this error, but just in case you face that error, remember you just need to replace that Asia, Kolkata with your time zone, and that's it. That will fix the error. Okay, now click on OK. And by the way, name the database. Let's just name it banking. Hit finish. There you go. Now we can see the database that we just created. We have the database now. Now we need to create the tables, and then we generate the data and load it into the tables. Our next step will be creating the tables. Right click on the database, SQL editor, open SQL editor. Let's create the tables. Before creating the tables, we need a plan. We need to plan how we need to create the tables and also how we need to connect them, because we are creating a database. So let's just have a small plan to do that. Let me just close this, and yeah, let me just go to Lucid Chat here, and in the shapes search for ERD. I want to select this one. Let me name it, let's say customers. And now just copy paste and duplicate it. Name it accounts. So a table for customers and a table for accounts and a table for transactions. Okay, now what would be the basic columns that should be in the customers? It should be, of course, the ID, and there should be first name, and last name. And now let me just create another row. Okay, right here. And then an email. Should we add phone number? No. Let me just add created app. So this saves the time when the customer account got created. customer entity, the record got created. So that's it for the customers, I think. Let's just take out these things. Oh shit. Yep. And ID will be our primary key for the customers. So let's say PK right next to it. So ID is our primary key for this dimension table. That's it for the customers, and now for the accounts. Of course, the ID will be the first, and then customer ID who is linked to the account. So customer ID. Okay, and account type, whether it's a savings account or a check-in account, and then balance in the account, and the currency type, and also created it. Okay, just check this out. Of course, ID will be our primary key, say PK right next to that. And now we need to relate the customers table to the accounts table. For that, we will be using customer ID, which will be the foreign key in the accounts, and we will be referring that to primary key like that. Name it FK. In case you're not familiar with these ERD diagrams, these basically an architecture that we prepare before creating a database, so that we will be sure what we're doing in the database. So we're just creating these tables to define the relationships and also the columns that we're going to create. And this line here shows the relationship. This is called as I think it's crowfoot notation. So it says the relation between the both tables with the symbol that is connected with. Let's say here, one customer can be connected to many accounts, but one account can also be connected to many customers, right? So this should be one to many. No, many to many can be represented with this symbol. And there's this symbol, it can be 0 to many. 0 or many, but the relation should be one or many. These are where we represent the ERD diagram. Now the customers is connected with accounts with the foreign key customer ID inside the accounts. Now for the transactions, let's say the first one of course should be ID, and the second one account ID. Just perfect. Transaction type, the row, amount, related account, low, and status. And also, of course, the created at time, created at. Well, the ID is the unique ID to identify the transaction, and account ID will be the ID of that account that is processing the transaction. And the transaction type can be deposit, withdraw, or transfer to another account. And amount will be the amount that is included in the transaction, and the related account will be, if it's the transaction type is a transfer, the related account will be the person who receives the money. So that will be that. And the status, is it processed, or is it processing, or is or is it failed? So a column for status, that is that. And let me take this out. FK, and ID should be PK. Here account ID will be the foreign key in transactions, and this will be connected to accounts. And the relation will be should be one to many. What did I just do? Okay, it should be one to many. I think that's the correct relationship. I think it is one account can have many transactions, but one transaction should only have one account. We can only transfer money from one account in one transaction, yes. So or it also can be many to many in some cases, but yeah, that's fine. We don't need to think about it a lot. Yeah, that is it. Well, this is not considered as a star schema. This is basically a snowflake schema where uh, this is a special case because the transactions is our fact table, and accounts and customer is our dimension table. Usually in star schema, both the dimension table should be connected to the fact table, but in Snowflake schema, there will be internal connections between the dimension tables, and then one dimension table is connected to the fact table, but customers is indirectly connected to fact transactions. These are the banking database connections look like. Okay, now we have the plan. And this is the best time to create the database structure. So we need to create 3 tables first: accounts, customers, and transactions. Let's start with the customers first. Create. By the way, dbeaver allows you to code in PostgreSQL, in case you don't know. So we're going to use PostgreSQL to type queries here. What is it? So create table. Why is it not in capitals? I'm trying to type in capitals, but yeah, what? No, I'm just gonna type the queries in VS Code because I have to push the SQL query as well to GitHub anyway. So I'm going to create a new text file. Say create table customers. Let's just keep the ERD diagram right next to that. Let's see. So the first column should be ID. Say ID serial primary key first name varchar not null. Oh shit. Let's do last name. Created at timestamp with time zone default. Now, well, we're creating a column named ID, which will be a serially increasing number. So we're using serial to make that increase. I mean, it basically generates a unique number, starts from starts from 1 to infinity. So it just increases one after another for every record. Starts from 1 to go and goes to infinity. And that will be our primary key. And then there is first name, which is var char, and the length is 100, and it should be not null, which means it should be filled. It should have a value in it. And also the last name is the same as first name. It should not be empty. We are using not null constraint to make sure of that. And also the email is the same. And it also should be unique. So it cannot be repeated in any other record throughout the customer's table. So it should be unique. And then created at. It captures the timestamp when the record gets created. So I think that's perfect. Now create accounts. And first will be ID, the same thing. Just copy paste it. By the way, you'll also have this. I know I already told you this before, but I'm going to tell that again. You can find all these codes and queries in the GitHub, and the link will be in the description. Customer ID. Integer, not null. References. By customers. ID. Say delete cascade. Count type virtual 50 no balance did I spell the balance wrong here? Balance numeric. We're going to specify the length of the length and precision of the decimal. It can be somewhere between 18 and precision as 2. Not null, default 0, check of balance is 0. Currency default. Set. Okay, here of course we created the ID to get the unique number for every record. So we specified it as serial, and it is our primary key for the account. There is customer ID, which is integer, cannot not null. It should not be null. So because every account should have a customer ID linked to it, and because this is a foreign key, it should have a reference, and the reference should be pointed towards the primary key of customer's ID. And we use this on delete cascade because to make sure if the customer ID gets deleted, the account also should be deleted. No, the customer ID in the customer table gets deleted. The customer ID in accounts is also should be deleted. So that's why we use cascade. And there is account type, and it should be var and not null, balance numeric, and this is the length and this is the precision. Shit. Yep. So in case if you're wondering, precision is nothing but defines the point values after the dot. Let's say you push a balance number as 10.2345. It only takes 10.23, only two numbers after the decimal point. So it only takes 2. That is what we defined as at the precision as 2. And we say not null. And by default, if you don't have any, if it doesn't get any value, by default it will be 0. And check equal 0. And currency, I think that's wrong. balance should be greater or equal to 0. It cannot be negative. That is that. Okay. Now there is currency, which is by default is USD unless we change it. So it will be USD. And this is where we capture the creation time of the record. And now we create transactions. ID. Big serial. Primary key. Account ID, transaction type, amount. I'm going to copy the same thing and paste it here. Char of 50, not null. Amount numeric. The length will be 18 and the precision will be 2. Check of amount is greater than 0. Related account ID int null status varchar 20 should be treated created at timestamp with time zone. Default now. Here, of course, we created ID, but the transaction ID should be different because there will be a lot of transactions, a lot of records in the transaction table compared to accounts or customers. So we're going to use big serial to extend the limit to big serial numbers. So we use big serial as the data type here. The same thing, primary key, and account ID is the foreign key for the transactions. So we use reference to customer ID, customers of ID. No, I think it should be accounts of ID. Yeah, it should be accounts of ID. My bad. Okay, so it should be accounts. So it should point to the ID in the accounts table. So it should be accounts of ID on delete cascade. Like I said, if the account ID gets deleted, the account ID in the transactions will also be deleted. Transaction type or null, amount numeric. This length and precision defined, not null. Check if amount should be greater than 0, and then related account ID int null, int, and should be not null. Should be null. Whatever. And then status is what varchar and 20 not null default. By default it will be completed unless we change it. And then we have created at timestamp with time zone, and yeah, to capture the current time when the record is created. And that is it with that. Let me see if there is any errors in these queries. I just found few errors, which includes here. I haven't typed in table for the accounts and transactions. Now that is fixed. And also I forgot to put semicolon at the end of every table definition. And one more thing, in PostgreSQL we cannot use double quotes for string. It should always be single quote. And I think that's it. Now save this file, and the path should be in our repository. It should be in Postgres, and right here name it schema, on capitals, schema.sql, save as tab SQL. Okay, should be dot save. Now let's just copy this and run it in our dbeaver. Run it one after another to see if they're actually get created. Perfect. Now if we refresh this, click on this and refresh, we should be able to find our tables inside the database. Here, and schemas, public, tables, accounts, customers, and transactions. Perfect. Now we have the tables ready. But what's missing is the data inside the tables. So we're going to generate the data by ourselves. So let's do that. To generate the data, I have a code for that as well. Let me just banking. Data generator. Fake generator. Head back to VS Code. Create a new file. Select Python file. Just happened. No, create a file. It's a text file. Paste the code here. Well, this is the fake data generator code that I used ChatGPT to create this. So it creates 10 customers and 20 accounts and 50 transactions for every 2 seconds. And let me just explain the code real quick. Here we are importing the modules, and now number of customers as 10, accounts per customer 2, number of transactions 50. So this says for every loop it creates 10 customers and 2 accounts for every customer, which means 20 accounts for every loop, and then 50 transactions, so 50 transactions for every loop, and max transaction amount is 1000, and the currency will be USD. Initial balance minimum decimal, so we are defining the variable initial balance as 10, which is a decimal, and then maximum initial balance as 1000. Default loop true, sleep seconds 2 seconds. So like I said, it loops for every 2 seconds. We can if you want to change it, you can change it accordingly. And then this whole block of code is for looping, and if we want to stop the loop, we can just click Control plus C. That's how that is what we configured in this code block. And then we imported faker. Remember, here we imported faker. That's what we're using here. Stop it, bro. And default random money. So this code block generates random money for the balance and also for the transaction, I think. Okay, this is the configuration block for the Postgres. It includes the host name, port number, and also database name, user, and password. We will be configuring that using .env file. Like I said before, we're going to store them in a separate .env file just to make it compliable for GitHub. So we don't code the actual credentials, the actual secrets inside the code itself. And then connection.automate and connect cursor equals connection.cursor. We use this to connect to an SQL server and write queries inside. And here, this is the definition, run iteration, customers. This is where we collect the customers, a list of customers. And in this loop, we are creating first name using fake.firstname, which creates a random fake first name and fake.lastname, a fake last name, and a fake.unique.email. We are specifying it should be unique for every record. So it creates a unique email and it is fake. And then the cursor, like I said, we use it to run the SQL queries inside the database. But then we run insert into customers and all the fake data that we generated into the customer table using this one, insert into customers, first name, last name, email, and then values and returning ID. So we return ID from this query. So because we need to use that ID when we create the accounts table. So we return the ID from the customers table here. Yeah, and we assign it to customer ID variable. And then it goes to accounts. We're creating an empty list named accounts to capture all the accounts. And we do almost the same thing. Customer ID in customers. And for every customer ID, like I said, for every customer ID, there should be 2 accounts, like we defined here. So for every customer ID, So this loops for 2 times because we specified it as 2, it loops 2 times. Account type, savings or check-in, it'll be a random.choice. We use random.choice method to pick one object from the defined list. And in this list, there are 2 objects. So it will pick randomly one of the object for every loop. And initial balance, random money, initial balance minimum and initial balance max. And I think random money, we defined it here. Yeah, so that generates a random money value and that will be assigned to initial balance for every loop. And then, like I said, we use this to execute a query inside the database. Account ID, and also here we return the ID, we return the account ID and we assign it to account ID because we will be using that account ID in the transactions table when we create the transactions table. Okay, and that is that. And now here, the step 3, generating the transactions, which includes transaction types, deposit, withdrawal, transfer, for in range of number of transactions, and number of transactions are defined as 50. So this loops for 50 times. Account ID, random.choice of accounts. Accounts are the okay. Now transaction type equals random.transaction types. Transactions is a list here, and the account ID is the accounts that we given here, we appended here. So it chooses a random account ID for every transaction and a random transaction type. Amount will be round of random.uniform 1 comma. So this is a method I want to say. So first let's take a look at this particular block. Random.uniform is a method that we use to pick a random decimal number in the given range, and the range is 1 to max transaction amount that we already defined here, $1,000. So it picks a random decimal number. This one picks a random decimal number from 1 to 1000, and then it will round. We use this to round it up to 2 decimal points and assign it to amount variable, and then related account equals none because we're just defining a variable now and we will assign a value later. If transaction type equals transfer and length of accounts is greater than 1, if there are more than 2 accounts in the accounts, related account equals random.choice A for A in accounts if A is not equals to accounts. This makes sure the account ID that is picked from this one is not equal to the account ID that will be picked for related account, because we cannot if it is a transfer, it shouldn't be the transfer between the same account ID, like I said, from the same account ID to the same account ID. If you don't get it, like, let me take an analogy. Let's say the account ID is 2. So you cannot transfer money from 2 to the account 2. It doesn't make any sense. So it makes sure it picks a unique account ID that is not equal to the account ID that is picked before and assigns it to related account. So that is the receiver, and the first account ID will be the sender. And this one, of course, the SQL query. And after that, it prints length of the customers, length of the accounts, length of the number of transactions, which will be, customers will be 10, accounts will be double the customers, which is 20, and then transactions will be 50. This is the main loop. We use exception here. There is try and there is exception. We use exception, like I said, to exit the loop when we click Control plus C. And we have try here, iteration 0, while true, iteration plus 1. Print iteration started. It shows the iteration started and which iteration is it. Not loop and yeah. And for every iteration, it runs this function, which we already defined here, right here. And yeah, that is it. And finally, it just closes all the connections to the database and it exits. That's what the code is about. Now let me just save this first. This should be saved in data generator and the name can be data generator as well. Let me name it a different one. Let me name it differently as figure generator dot py. Should be Python file and save it. In order to run this fake data generator, we also have to create a new file, a new .env file, and assign the configurations, assign the credentials to it. To do that, let me just create a new notepad file here. Now let me just use these names. With the Postgres host, be localhost, and the port number is our Postgres port number 5432, and then database is banking user Postgres. Save this file. Inside data generator should be .env, type all files, and encoding should be UTF-8. Now save it. Now we save the secrets. To call the secrets into the Python code, we first need to define, we need to import OS and also import now from .env import load.env, and then it goes load.env of then for the configuration we need to do os.get env of I'm going to copy paste it. That is it. Like I said, we're doing all this to comply with the secret rules. We don't want to upload all this. We don't want to push all these secrets into the GitHub as well, because they're supposed to be secret, and that's why we don't hard code our secrets or any credentials into the code directly. We save them in a file, in a .env file, and then we call those credentials into the code, and then this code will be published onto GitHub. And that doesn't, I mean that, and because we don't want to risk our credentials by pushing it into GitHub. So we don't hard code the password. Instead, we save the actual credentials in a .env file, and we don't push that .env file. So those credentials will not be exposed into the GitHub repository. And we refer those credentials using os.getenv and the names to address every single object in the credentials. And that's it. Now I think we are ready with the generator code. But before running this generator code, we need to install the requirements that we need. For that, I already created a .text file, which is my home page. This one right here. This is not another code file. Like you say, it is a requirement.txt file. So you don't need to install every single thing one after another. You can just run the whole file, the whole requirements.txt file, and install all the tools at once. So I just want to make it easier for you to install all these tools. So yeah, you can find this requirements text on GitHub. So copy that text and paste it in a new notepad, or not necessarily notepad. You can just paste it in VS Code instead. File, new text file, paste it here, save it on your main repository with the name requirements as plain text, save it. So now you need to install the tools and the requirements inside VS Code and also on your host system if you want to. So I'm going to install on both the environments. First, I'm going to install on my system. To install that, click pip install -r requirements.txt. Now it is getting installed. If you don't want to install those tools on your PC, that's completely fine. You can just install it in your VS Code in this environment by opening the terminal. I'll show you that later. Let me just first make sure this is getting installed on my PC first. It might take a few seconds because there are a lot of tools that are getting installed. So let me just pause it. Okay, now the tools are successfully installed. They're on our PC. But to install in this environment, in VS Code environment, click on Terminal on the top right corner and click on New Terminal. Here, run the same command. Let me just copy that. After the, okay, it says requirement already satisfied because I already installed those all tools inside this VS Code. Okay, now the tools are installed. So after the project, if you want to uninstall all the tools, you can just use the same command, but change this install into uninstall and run the command. And all the tools that we installed will be taken out from your PC. That's it. Now we have that. Now let's run the faker code. Say here. Run it. Like I say, I'm going to run it for 5 iterations and then click Ctrl+C like that. Now, so I iterated 5 times and I stopped it at the 5th time. Like I said, it generated 10 customers and double the customers or the accounts, which are 20, and then 50 transactions for every 10 customers and 20 accounts. That is iterated for 5 times, which means we have 50 customers and 100 accounts and 250 transactions. These should be in our server, in our Postgres server. In order to see that, we need to refresh first. And now let's just query. Let's create another SQL editor, new script. Here, run select all from customers. Now if we run that, there you go. There's all the records. Like I said, we defined the ID as serial, so it increases from 1 to infinity. So every record gets a unique ID, and we generated 50 records. And let's check for the accounts as well. Copy that. Accounts. So account should be 100. Double the customers. And yes, we got that as well. It has the customer ID, and every customer ID has 2 different accounts. Yes. And that's exactly what happened here. You see, customer ID 1 has 2 accounts created, and randomly generated balance, and account type is random, checking savings, and yeah, perfect. And same for transactions. Transactions should be 250. 250. And few of the related account columns are the related account rows are null because of the transaction type we chosen. If the transaction type is withdrawal, there will be no related account, yes, because there is just one account that is happened that is related to this transaction, which is our main account. So there will not be a related account. If it is a withdrawal or a deposit, there is only one account, which is the main account. If that is a transfer, this will be the main account, and which will be the sender, and the related account will be the receiver. And that's why a lot of these rows are empty in the related account column, and status is all completed. Yeah, perfect. Now we're all set with the first step now, but don't worry, the next step will be faster. I know this took longer than expected, but the next steps will be faster. I will try to make it faster so you don't have to spend a lot of your productive time here. Okay, now we're done with the data source, which is our database. Now heading to data streaming. We need to create a Kafka plus Debezium stream. Let's do that. For the data streaming, I also have a code for that. Let me just open that real quick. Open with Notepad and copy the whole thing into VS Code. Create a new file, Python file, paste it. Now let's take a look at this code and know what we're actually doing here. Well, we import JSON to convert the data into JSON format. We cannot stream all the data structure that is in the database, so we need to convert the data into JSON. So using JSON.dumpsoff. If you remember, JSON.dumpsoff is the method that we use to create a dictionary into JSON file. And then import request. We import requests to create a HTTP request. And this whole code block is the configuration for the connector. And this is the connector name, PostgreSQL connector. Yeah, this is all the connection configuration. But this line right here, I added this line to handle the decimal values in double data type. If we don't specify this line, this Debezium connector will automatically turn the decimal value into a string referral in a binary as a binary referral. So to not convert this decimal into binary, we have to define it as a double data type here. And that's what I did. Decimal.handle.mode equals double. This is a request. This is to send the request. We created the URL, we crafted the URL here, and the header for that. And the response, like I said, we use request to send HTTP requests. And JSON dumps off to convert a dictionary into JSON file. And yes, and this response will be captured with a number, and with that number we'll know what happened actually. If the response is 201, that means the connector created successfully, and if it is 409, connector already exists, and anything else is failed to create the connector, and it prints it so that it will be easier for us to debug if there is an error. And if you take a look at the configuration, the connection configuration, we have to enter these secrets, which are port number, host name, user, password, database name, which should be in .env file like we did in the other codes as well. So let me create a new text file, and let me just fill up them first and then assign the values. Equals. The host name, the Postgres. Oh, my caps lock is turned on, sorry. Postgres. Port, I think it's 5432, yes. 5432. User is also Postgres. Password is also Postgres. The database is banking. Now let's save this inside Kafka Debezium folder and name it .env. You can also find these .env files in the GitHub, by the way, but I will remove my credentials and I will replace them with placeholders like this. I'll just use the lesser and greater than symbols and fill them with the placeholders so you can fill your credentials. Okay, now .env all files and encoding UTF-8, create, save that. And now here, first we have to import OS. OS. Same thing that we imported here and this one too. Perfect. And here os.get env of colon parenthesis. Just copy paste it in every single line. Same thing, repeat the same thing on the other side. Yep, perfect. No, to take this out. Now it's perfect. And what else should we fill? Wait, sorry, the topic name shouldn't be this one. We can just write it here. We can just name it anything, any random name. but if it is related to your project name, it will be easy to remember. So the topic name will be banking server here, and the slot name, banking slot. And yep, that's it. Now save this in Kafka Debezium. Name it, let me just name it the same as I did before for the other file. I'm going to name the same thing. Should be in Kafka Debezium. Name it the same, .py, Python, save. Now it is saved. Now let's run this. Let's go to this one, run it. Extend the terminal. What it says, connector created successfully, which confirms the connector is connected to our Postgres server. Now the data is ready to stream. The data is in the stream. Now we need to pull the data out, which means we need to run a Python code to get the data out of the stream and store it in our storage account, which is min.io, which acts as our S3 bucket, just like our last project. And the code for that is, I think I named it consumer, Kafka to min.io, yes. Copy that. Go to, let me just close a few of these files because it is flooded with all these files and hard to recognize each of them. Okay, that looks clean. Now create a new file, Python file. Now paste the code. And by the way, for this code, I haven't replaced these credentials. I mean, I already set this by default as os.getEnv because it's taking too much time to write them by my own on camera. So I just left them as defaults. This is my original code that I already ran before. So I already have this code with me, and the credentials are also saved. Let me open that file as well. .env, notepad, just once, right here. Oh, well, the credentials will be typed by me, but you know, that .env file is already created. I just need to copy paste it and put in my credentials and run it. Okay. Now, before going further, let's understand the code. Well, starting with import Boto3. Boto3, we need this module Boto3 to connect to any S3 compatible storage space. Well, we're not using, like I said, we're not using AWS S3. Instead, we are using something similar called min.io as our storage space. So we need Boto3 to connect to that, and then we import Kafka consumer from Kafka because this code is a consumer code. We need Kafka consumer for that, and then we import JSON because we're going to deal with that. I'll show you why we imported JSON. And pandas is a data manipulation tool. We need that. And then date time to capture the present date and time, the present timestamp, we need this module as well. And then these two modules are for pulling out our credentials from .env file. And yeah, load secrets from .env file, we need to do this first. And this whole code block is the configuration for Kafka consumer. And here we specify the tables that we need to extract: banking server, customers, accounts, transactions, bootstrap servers, offset reset, earliest, enable auto commit true, group ID. Here, right here, you need to take a look at this. We use this line to deserialize. Basically, whenever we stream on Kafka, the data gets serialized into binary bits and then streamed by Kafka. So when we consume the data out of it, it is still in binary form. We need to convert it, we need to decode it. So we use this line. And at this particular block, it decodes that binary bits into the regular data, and then, into the regular JSON string, which it's supposed to be. And then that JSON string will be converted to dictionary using json.loads_of. And that's what we're doing here. And this line, auto offset reset, makes sure it renders the data from the beginning of the stream and not the upcoming data. So there are few methods for this offset reset, which is earliest, oldest, and few more methods. The earliest makes sure the data will be, it captures all the data that is on the stream. And we use resource group to capture the offsets, which means, let's say your consumer stops, your host machine stops, and consumer automatically stops. And when you turn it on, you don't want to render all the data that from the beginning of the stream. You want the data from the point where you stopped it. Yes, so that's why we use group ID to save the offset where the machine got stopped, and then when we start it, it starts from where it stopped and not from the beginning, which creates duplicates. So to avoid duplications, we use group ID to save the offsets. And just close this. Yeah. And yeah, that is that. And now this is the configuration to connect to min.io. Like I said, it is S3 bucket. It is a kind of a close replica of AWS S3. So yeah, S3 URL access key, secret access key, and then bucket. The name will be specified in .env file as well. And yeah, if the bucket doesn't exist, it creates a bucket in the code itself. And now the data will be written into the min.io using this definition. Yeah, this is where we store the data inside min.io, and we specify the format. And we will be using Parquet. If you have seen my previous videos, I already talked about Parquet files. Parquet files are the best way to deal with big data because Parquet files take less space, and also it stores the data types of each column. And that's why we use Parquet files. It is best to use Parquet files while you're dealing with big data. It is a lot better than .csv file or JSON files. Yes, we are going to save them, the files in Parquet files. Whenever we save that, we will be printing this dynamic string, which shows the length of the records and also the bucket and the key to confirm the data is getting ingested, just to make it easier for us to debug if something went wrong. And then this is the batch size. We are specifying a batch size here. So if we just send 30 or 40 or anything, any records, any number of records less than 50, it won't get pushed into min.io. Only when this batch size satisfies, that batch size amount will be pushed into min.io, and the rest will be left waited until the total gets to 50. So that's the batch size we defined. Yes. And after it gets connected, this message will be printed. So this is used to debug the code. If something went wrong even before the connection to the Kafka, we will know because this will not be printed. So that's why we use this static print string to debug. And then there is a loop for message in consumer topic equals message.topic. Like I said, the message from consumer has a lot of extra data rather than just the data that we need. It also consists of the metadata, which is the data about the data. So we don't want that extra data. We just want the data that we streamed, which will be the message. So the message.topic pulls out our actual data, our actual required data out of it, and stores it. Yes, that is that. And we use a buffer to wait until we get the 50 records to push it into min.io. Yep, and that's it. Let me just save this real quick inside consumer and name it. Let me just name it the same thing as named it before. Should be in consumer Kafka to min.io. I want to name all the files, all the new files as my old files, because if something went wrong, it is easier for me to find out. Okay, consumer, paste it. It should be Python. You don't need to put .py again at the end because we already set the file type as Python, but you know, it is what it is. If I want to, I can fill. Okay, now it is saved. Now we need to save the .env file, which is also here. And for the configurations, firstly, the Kafka port should be host Docker or something. That should be in our Docker compose. There is our Kafka. This should be our port. Host Docker internal 202. Paste it here. Kafka group name. Any name that you like. I'm going to name it min.io landing group. And min.io endpoint port. And also this should also be in our compose code right here, 9001. Let me fill that up real quick. HTTP user as min.io, min.io admin, bucket name. We haven't created a bucket inside our min.io, so let's go ahead and create that first. Create bucket and name it raw. Now we have a bucket ready where we can save our data, store our data. Just name it raw. Save this file. Oh shit. Well, in that case, let me just save as and point it to a repository consumer.env, type all files, encoding UTF-8, save. Perfect. Now we have the consumer. So let's just run this and see if it works. Oh, it's saved as env.text. That is not good. That shouldn't be text file. Something went wrong. I'll just head to my repository consumer. Oh, it's saved as text file. Open that. Let me save that again. Save as .env. Should be all files. Save. Replace. Still says as text file. Let me just save that again. .env. All files. Save. No. Oh, something's going on. Let me just copy this and delete this totally. Okay. Create a new notepad and paste it. Now save it. .env. All save. Perfect. Now it works. Okay, we have the .env file and consumer as well. Now let's run the consumer. Okay, it works. Obviously it will work because I copy pasted the code. So yeah, it says connected to Kafka, listening to messages, and it is listing all the messages that is getting saved into our storage space. Now we should be able to see, if you refresh, we should be able to see all our data inside the storages. And they are stored in .parquet files, which is best for big data, like I said. Customers, and with the date as well. Date. And because it is partitioned into 50 files, there are just a few files, and each file has 50 records in it. And okay, we got the data in min.io. Now let's head to this. Now, like I said, the next process will not be so time consuming. It will be easy, like I said. So now we are done with data streaming and also data storage as well. So these two steps are done. Now we have to use the code that pulls out the data from min.io and stores it into raw tier inside Snowflake. And we need to orchestrate it with Airflow because the whole data pipeline should be automated, and it shouldn't need any human intervention. So yeah, we are going to orchestrate it using Airflow. We need a Python file which acts as our DAG file that says Airflow the task that it needs to implement to pull the data out of the storage account and store it inside the Snowflake's bronze table. In case if you don't have a Snowflake free trial account already, just go ahead and create one. Just go to Snowflake free trial account, Snowflake trial. And the best thing here is you don't need to put in your card details at all. You just need an email ID, and you need to fill the rest of the details, and your account will be activated, and you will be given free trial for 30 days with a $400 worth of free credits you can use in these 30 days, which is the best deal in my opinion. So yeah, create one account. Well, I already created mine. I'm going to log in to my account. This is the home page that you will land when you create your Snowflake account. And right here in the bottom left, you can see your credits that are left on your account. Mine, I still have 287 credits because I already worked with 2 projects, and I have 11 days left before my free trial get expired. Well, that is that with the Snowflake. Now, after you create the account in Snowflake, I have the DAG code with me, but first let me just stop this consumer. It's just waste of computation power, so I'm going to stop this consumer. Yes, for the DAG file, DAGs in IO DAG. Let me just copy this. Also close these rest of the files. Paste it in VS Code, new file, Python file, paste it. Just shorten this up. Yes, this is our DAG file. And let's take a look at what we're dealing with here, right? And yeah, import OS, like I said, import OS and .env, both these modules are used for importing the data inside the .env file that we are going to use to pull the credentials out, which offers us to not let our credentials to be hard coded in our code. And then we have Bodo 3, which used to connect to S3 bucket. In our case, it will be min.io. So we need Bodo 3 to connect to the S3 bucket. And then we have this import Snowflake connector. Snowflake connector is used to connect to Snowflake, like it says. And from Airflow, import DAG. To make it a real DAG file, we need this module. From Airflow operators.python, Python operator. And then from datetime, import datetime, time delta to capture the present time. And of course, this one to load environment variables. This whole code block is min.io configuration, and this code block is Snowflake configuration. And then we have tables, customers, accounts, and transactions. Yeah, I'll try it. Well, these are the three tables that we're going to store the data in. We haven't created these tables yet, but we will create these tables in Snowflake. And yeah, this is a function that downloads the data into MinIO and stores the data, downloads the data from MinIO and stores the data locally using this one, this dictionary. And then this stored local files data will be loaded into Snowflake using this definition, this function. Take a close look at this. Right here, this is the configuration to connect to MinIO and pulls the data out. It adds the prefix for the file name, and the bucket is specified here for the bucket name, and yeah. And then this function loads the data to Snowflake, like I said. And right here, this whole code block is the configuration, and this is just in case if there is no files in MinIO, this gets printed. It says no files found in MinIO. There is a static string that gets printed. And this one, connection cursor, is used to write an SQL code that can be executed in any SQL server. In this case, it will be the Snowflake. So we will be doing for loop, print no files found in table. And here we use copy SQL f strings, and we will execute this query using cursor.execute of copy SQL. And then we close this. Owner, this is all the Airflow DAG part from here with the DAG, and this whole function downloading from MinIO will be assigned to task 1, and the rest of the whole function that loads to Snowflake will be assigned as task 2 for the Airflow right here. This is the task 1 that is defined. It says download MinIO. You say Python callable download from MinIO is the function that we defined right here. The same thing for this one. Task 2 will be load to Snowflake. This function right here. So that is task 1 and that is task 2. This defines the flow of the task that needs to be executed by Snowflake. And yes, that is that with the DAG part. Now we need to put in the credentials into this. To put in the credentials, I think I haven't opened the .env file. Let me open that first. .env, just once. And here, the MinIO port. First, let me just copy this whole thing into a separate notepad file, and here for the MinIO port, something as http:// and the username and password should be in this file. No, sorry, should be in this env file. MinIO admin. The user, for the password, and also for the bucket name. The bucket name is raw. The storage, local storage specification, and Snowflake username should be your Snowflake username. Mine is J, and the password Oh, I'll fill the password at the end. Okay, for the account. For the Snowflake account, you have to head back to Snowflake. And in the bottom left, click on your profile and click on session details. And here, Snowflake context. Copy this part of that. Right? Copy this part until the dot snowflake computing. And then paste it here. And for the warehouse name, in the compute warehouses, compute WH. Copy that, paste it here. The database name, we haven't created a database yet, and so we also don't have a schema. We have to create them first. So head to Snowflake. Now click on the plus icon on the left pane. Click on that, click on SQL worksheet. Now let's create a database first. Create a database, and with the name banking. Run that. Database banking successfully created, and it should be visible in the catalog here. There you go. And doesn't have any well, it does have default schemas that provided when for the new database, but we need a separate schema for our project. To do that, let's create the schema first. Create schema. Banking. By the way, this Snowflake SQL is not case sensitive, so you can just write in capitals or small, it doesn't matter. But you know what? Let's just write small letters. Banking dot, and the schema name can be, no. First, let's create the schema name as raw. Create schema raw. Executed. Schema raw successfully created. When you saw it should be now visible. No, first you need to refresh the catalog, and yeah, there you go. It is created. Right now it is empty. So let's create the tables as well. Head back to SQL. To create the tables. Make sure the notebook is connected to the right schema, which we just created, banking.raw. Make sure that is connected to that, and now create table, customers, v, variant. I think I spelled it wrong. Should be variant. Yep. That's it. Well, we haven't, if you take a look at it, we haven't created any structure for that data. We just created one column. I mean, we are going to create just one column. Run this. It is created, but it only has one column, which is named v, and the type as variant. Variant is a special data type which Snowflake offers, so that you can save any kind of data type of any length into this column, and later you can just manipulate the data afterwards. So this makes it easier for us to just dump all the raw data into just one column. So we created the customers table. Let as well create the rest of the tables too. Accounts, and transactions. Transactions. Just create the accounts first, and also the transactions. Now, if we head to catalog again, refresh first, extend the banking, and extend raw. Wait, there you go. Under tables, you will be able to find all the tables that we created. If you click on that, go to columns, there is just one column which is variant type. Okay, now the Snowflake is ready to get the raw data in. That being said, we also have, now we should enter the database name, which is banking, and the schema name is raw. Save it inside the Docker DAX. DAX is what Airflow created when we composed the file. Inside the DAX, and name it .env. Type all files and encoding UTF-8. Perfect. Now head back to our main code, which is Kafka to min IO. No, sorry, this one, my bad. Now save this code in the same location, Docker DAX, name it, wait, what? min.io to Snowflake tag. Perfect. Like I said, you can include .py or you can just select the type as Python. Both works. It's fine. All right, that is saved. Okay. Now, if we open Airflow and make sure the auto refresh is turned on, now we should be able to see the DAC file that we just created. Now we can see our DAC file that we created. Now turn that on and then it automatically gets executed and wait for a few seconds. I think something went wrong. It is up for a retry, which means something went wrong. Well, we got an error here, but here's the thing. Whenever you get an error in a DAC file in Airflow, you can check the error by clicking on this button right here and click on the DAG name. And here you can see two blocks because we assigned two tasks, remember? One is download bin.io and the other one is load Snowflake. So it failed at the first task itself. So click on the first task and then click on logs. And here extend these two. You can see the exact error. Sometimes it is just a single line error which is easier to debug, but this big error is so hard to, takes a long time to read the whole thing. So what I actually did here is we basically go to the end of the error, and you will probably see the error at the end. And I can see the error right here at the bottom. It says custom endpoint here. Endpoint I specified as HTTP instead of HTTP, and that is the error. I just found it out right now, but in case you don't find it out, you can't find the error. You just copy the whole error and ask ChatGPT. It gives you the reason of its failure. Right here, I just pasted the whole error. I haven't said anything. I haven't posted any prompt to the ChatGPT whatsoever, but it automatically identified the error right here. It says fix. In your .env file, you have to use this one instead of this one, which I used as HTTP. It should supposed to be HTTP. That's my error. So now I know my error, so I have to fix it right here. It should be HTTP. Now save it. Just stop this run. So I'm just trying to run that with a new file and see if it is fixed. Well, it still shows the error because I have to. It still takes the old file. I have to stop this. Let me see if it takes the old file still. No, no, it doesn't take the old file. Now we have another error, a new error. Let me see what the new error is about. By the way, this new error is now at the second task, not the first task. The second task, it says it to the end. Password is empty. It says password is empty. Yeah, password is empty here. I haven't entered the password yet. I said I'm going to enter it at the end, but I forgot. Okay, let me just pause the recording and enter the password and run the tag again. Well, now I did enter the password again. Now it should be all right. Let me execute it manually. Stop these two other executions. We don't need them. There you go. Now it is successful, which means we should be able to see the data in the catalog. If we refresh this under the raw accounts data preview, right here it says 100 records, which is perfect. And the customer should be 50 and the transactions should be 250. We got all the data. If we go to data preview, we should be able to see all the data that we generated. Nice. Now we're done with this step as well. We orchestrated with Apache Airflow. We pulled the data out of a storage account and saved it in bronze tier table inside Snowflake. Now we need to transform this data into silver, and then we have to go to gold. Now the real fun begins. Now we need to do the transformations. We are going to use DBT for the rest of the process here. Well, to start with the data transformation, we need to initialize the DBT first. To do that, open PowerShell again, head to our project repository, banking model and data stack. Here run dbt init banking dbt, hit enter. Okay, just enter number. Well, we are using Snowflake, so we need to enter 1, hit enter. Now account, and it also specifies what it needs, this value. So we need to head to Snowflake, bottom left, session details, copy this. Oh, not the dot, just this. Go back, paste it, enter. Username -j. Authentication mode, hit 1, which is password, enter. And now enter the password. Right. Role, no. Role should be account admin. Account admin. Warehouse name. Compute. Warehouses. Compute with WH. Copy. Copy. Paste. Enter. Database is banking. Schema. No. Schema should be analytics. We're going to create a new schema now. So before running this, head back to Snowflake, create an open any of the worksheets, and create another schema, a new schema. Well, this schema is just for the raw data, and this schema is for the analytics data. I mean, the rest of the silver and gold data. We're going to create and name it analytics. Analytics. Run it. Now we created a new schema. Now copy this schema and paste it here. I think it's the same thing. So yes, enter. Threads, I'm gonna go with 4. Okay. Now if we run dbt debug, we should be able to see if it can be error not found. Okay, let me see that. Head to this project, dbt project YML not found. Well, it is right here. One check failed. You know what? Well, it says the DBT project is not found, but it is right here. You know what? We'll just continue with the flow and see if it works. If it doesn't, we'll deal with that error. Okay, for now, we have the schema and we have the DBT initialized. Now we're going to create a staging view where we structure the data that is right now in a variant data type. So we are going to create a few SQL codes for that. Okay, let's head to VS Code, file, new text file, and here we type in the query here. Conf config. So Snowflake has this feature. You can just define what kind of entity you are going to create. In this case, I'm materializing it as view. So I'm going to create a view for this. ID will be string as customer ID. So yeah, ID should be string because we are not going to do any arithmetic operations with ID. And in case you're wondering, this is a Snowflake exclusive language. It seems different. It seems quite different than a normal SQL. And this is how we define the data types here. We are converting, we are taking out ID from V and defining it as string and aliasing it as customer ID. That is what we're doing here. And V first name string as first name okay V last name is also string as last name V email is also string as email created at we're going to create an exclusive timestamp for this staging table so it captures when the data is getting in. Created at V no I think that's it. Oh, this is the sorry. This is the time when the record is actually pushed into uh, the Postgres server. So this is the time when it gets pushed into the Postgres server, and this is the time when it gets into this staging table. So this particular method captures the current timestamp. Then we do row number. Oh shit, I just forgot to use the capitals. I think that's fine. It still executes anyway. It's case sensitive. The Snowflake is case sensitive, so it still does execute. I mean, the DBT as well is case sensitive. It is not case sensitive, so it doesn't matter if you define them with capitals or with the small letters. Customer ID. Let me just copy paste this. Well, what I did here is I selected uh, every single column from the variant data type, and then I defined a data type for that, and I aliased with a proper name. So the customer ID is aliased as customer ID is, I mean, the ID is aliased as customer ID, and the rest of them are all given a proper name with a proper data type. And here, until here, it's just fine. Here we just captured the current time, which captures the current time when the data actually reaches this staging view. And here, row number of over partition by ID. It partitions the data according to ID. So it creates a small blocks of tables partitioned by ID. So one separate block for ID number 1 and another separate block for ID number 2, like that. It partitions like that, and then it orders that particular partition with created at, which is the time that uh, when the record reaches the Postgres server. So it orders by that as descending order. So the highest value gets to the top. Why we are using this here means there is a reason for this. This is basically this is mainly for SCD2 compliance. Let's say a customer ID with 1 as 1 has an email ID, let's say as temp@gmail.com, and then he changed that email ID to temp2@gmail.com, which means the old record that is already in the database, already in the data, should be either deleted or replaced by the new one. But in SCD2, we are not going to delete the old record, like I said before. We're not going to delete the old record as well. We'll be tracking the history, but the historical data will be given the status as inactive, and the new record is given the status as active. That is what we're going to do. To do that, here, because ID, wait, here, because ID repeats multiple times, if there is any duplicate IDs with a different uh, dimension inside the record, like I said, if the same ID repeats twice but with different emails, this only picks the new one. This only picks the updated one and deletes the old one. All right. And that is what we are doing here. And you might wonder, if we delete the old one, that doesn't make any sense because we cannot implement the SCD2, yes? But the next step we are doing, we will be capturing the old one in that step, old data in that step. So this is just, for now, you need to remember that it will just capture the latest record for every unique ID. Okay, now that is that. Materialized view, and this right here, we did this separate. This is called a CTE, common, I think it's common table extension. It is created, it acts like a temporary table where we can do these manipulations, and then we can call those all columns into a separate table like this. We are selecting customer ID, all customer ID, first name, all the columns into here from ranked, and where rn equals 1. We are using that condition to filter the new records, the latest records for that particular ID. That's why here we are using CTE, common table extension, and we are pulling out the latest records. That is what we did here, and let me just save this into our repository, banking DBT, where we initialize DBT, and inside models, inside models, right here, let's name it, because it is a staging table, we're going to name it staging customers dot SQL. So it thought the language is Ruby, so it says Ruby, but it should be SQL. SQL right here. Save it. Now we have the customer staging table. Now let's create a account staging table. New text file. For this, we're going to follow almost the same structure, just like this one. So let me just copy paste it, but I'm going to change a few things here. Firstly, we need to change the account ID, and then there should be another underneath. Customer ID string as customer ID, and then account type, and then balance, currency, oh wait, I can redo this and then paste it here, currency and created at current timestamp, and for this ID the same thing, created at, this stays the same, source should be accounts, And let me just copy paste this here and remove the rest of the part. We don't need this. Yeah. This from ranked or n equals 1. That's it. Now save this as well in the same spot, models. And by the way, delete this folder right here. Delete that. And type should be SQL, STG, accounts.sql. Nice. And now for the transactions, a new file, new text file. I'm going to type it myself, except the first line. Oh shit. Select ID as string as transaction ID, fee account ID string as account ID. Just change it to capitals. So I will know it is part of SQL. Okay. V amount float as amount and then the transaction type. V status as string transaction time Okay, so this is not so bigger than the other two tables because other two views because we're not implementing SCD2 for fact table because they are all transactions. They will not be updated anytime in the future. So it doesn't need SCD2 for this. So it is just a basic uh, view. We're just defining the data type and changing the aliasing the column names, and we're defining the source of the data. That's it. We're not doing any of the stuff like picking the latest record and doing that, ordering any, so no any of those orderings and partitions like this one. Well, here we created the first column as ID, account ID, amount as amount, transaction type. Here we change the column name as transaction type, the full name, because it is good to see the full name for the analytics part. Related account ID, status, created at, current timestamp, which is the current timestamp when the data reaches a staging table. That's it. So we got that. Let me save that as stg transaction dot SQL should be SQL file. Save it. Well, we have the staging tables ready. Let's run them and see if they are actually working. To see that, let's go ahead and run DBT run. Now, we should get inside the DBT banking DBT because that is where we initialize the DBT. Now we have to run this command dbt run. Compilation error model depends on source raw accounts which was not found. And I just found out why. I forgot to define the source of the data. So let's define that. Back to VS Code, create a new text file. We have to define sources. Tab. Name as raw. Raw. Come on. Database. Banking. Schema. Raw. Tables. Names. Customers. Accounts. Transactions. Now save this. right here inside models and name it sources.yml. Like I said, you don't have to define it as .yml, well, because we already set the type as yml, but no, it is what it is. It doesn't matter. Now we have the source. And this is the best time to run DBT again and see if it works. Before that, I also forgot to add version to the version for that. Now I think it's ready. By the way, you think I'm getting a lot of errors and you want to pass all these errors. You don't want to deal with these errors. You just copy the codes that are in GitHub because they are all run and tested. So there is no way you'll get any error if you use those codes. This is, I'm typing it right now, so I am getting a lot of errors. But yeah, if you don't want to deal with these errors, you can just use those codes. Okay, now let's run this. DBT run. Okay, it is successful, which means we should be able to see those views inside our catalog if we refresh them. Refresh, refresh, refresh. Under the analytics schema, let me close the raw. Views, staging accounts, data preview. There you go. And just make sure all the columns are correct before before proceeding further. Yes, the transaction ID, account ID, amount, and transaction type, related account. And yeah, they are supposed to be null. Like I said, just for the transfers, there will be some account assigned, but the withdrawal and deposit, there will be nulls for related account ID, status, and transaction load. Okay, that is good. Now, the next step. Here's where the actual SCD2 starts. We will be capturing the old records using snapshots. Well, there is views, there is tables, there is snapshots. Snapshots are nothing but uh, the the place where the historical data can be captured. Even if it is not in the staging account, a staging table, it is still be captured in snapshots. So we will be creating snapshots for accounts and customers. So we'll be creating 2 snapshots. So for that, let's head back to VS Code again. File, new text file, defining the type as snapshot. Packet schema equals analytics. Analytics. Unique key equals Now, what we're doing here is we're defining a snapshot, basically. Remember when I said we're just uh, capturing the latest record for every unique ID in our staging customers and staging accounts, but the historical data will be stored using snapshots. So if let's say a customer with customer ID 1 is in the records of staging table right now, and this data will be stored. This will this data will be taken a snapshot using this snapshot, and then whenever the ID, whenever the any of the data of that particular ID changes, it has the old data and also the new one stored at the same spot, and it also assigns the active from and the active to date uh, for the old data, so we will know which one's new one. It might be confusing to hear, but if you will, I'm sure you will be cleared when we execute this, and I'll show you how it works in Snowflake. So this is the snapshot for customers. Let me save it first. And not in models, we have to save it in snapshots folder inside banking DBT and name it customers snapshot dot SQL. SQL. Save it. Same with the other one. For the account snapshot, let me just copy, you know what, let me just copy the whole code and name it accounts snapshot. Account snapshot, config, target schema, analytics, the same thing. And unique key should be account ID. And there should be check STG accounts. Yes, that's it. And check columns. I think I forgot to explain what check columns is and the strategy is. Here, the target schema is the schema where it executes, and unique key may explain this one. And the unique key is the key, it sets itself as unique. It should be unique and it cannot be repeated. All right, so the unique key will be customer ID in customer snapshot case, and strategy will be check. There is check and there are a few other strategies, but we're going to use check. And there is also a strategy that the changes that captures the historical data based on the time the record enters. But here we are using check, and using this strategy, we can create a list of columns that it will check. And here we define first name, last name, and email. So any of these three columns changed, the snapshot considered that as a change, and it saves the historic of the old record, and it creates a new record with the status as active. And that is what it does here. Now in the accounts case, these check columns should be changed. Unlike the customers, here we do the customer ID, because customer ID can be changed for the account, and account type can be changed, And the balance, of course, balance will change. And everything's good. Now save it in the snapshots and say accounts, snapshot dot SQL dot SQL, save. Okay. Now we're done with the snapshots too. Now what we can do here is, I think we can just run the snapshots first, or you know what? Let's create the final tables as well, the business ready tables, and we can run the DBT at the end. Okay. Let's save this first, and now create a new file, new text file, or we can run the snapshots first and see if they're working. Okay, let me just run them real quick. To run just the snapshot, we run dbt snapshot, running. Successful, which means we should be able to find those snapshots in the tables, customers, data preview. Yep, that works fine. So whenever a new record with the same customer ID but a different email enters the database, this, you see, like I said, DBT SCD ID, slowly changing dimension. This is specially designed for slowly changing dimension to be specific. So DBT updated at DBT valid from and DBT valid to. Right now you can see all the DBT valid to are null because there are no duplicate IDs entered into the database. That's why they're all null. If there is a duplicate, let's say a customer ID with number 1 has a duplicate, if he changed the email ID, the customer ID 1 changes the email ID, then another record gets added to this snapshot, and the old record, which is this one, will get a date for this dbt valid to, and the new record will be added, and dbt valid from will be the time that when it gets to the snapshot will be captured there, and dbt valid 2 will be null for the new record. That is how it stores all the historical record data. So it is a best thing to go for the SCD2 here. And yeah, the snapshots are working. Now we need to go create the actual table for the business ready data. And this is pretty easy because we don't have anything to do with any of the manipulations, because our data is already clean. We can just do config materialized as table materialized. We'll materialize this as table. You might wonder why we materialize that as view and this as table, because there are equal pros and cons for both of them. Table takes less time to render. When if you say let's say if you want to query some data, table takes less time to get the output for you, but view takes a long time because it references a table to get the data. So it goes to the table and asks the data from the table, and it gets the data to you. So it takes time to render the data. Well, table is faster, but table will not update the data automatically, whereas view, the data in the view updated with the parent table. So that is, they both have their distinct pros and cons. it depends on the situation which we use them for. Okay, so we are going to use a table here, and latest as customer ID, first name. Let me just copy that from here until this accounts here until the created at. Great. DBT valid from. We create a case, then DBT valid to is null, then true, else false, and as is current from customer snapshot. Just paste here. Select all from latest. Now here, we just all these columns are just regular staging table columns, and these time frames are captured from the snapshot that we created. Right here, see dbt updated data updated at dbt valid from dbt valid to. So we're going to use dbt valid from and dbt valid to, and call it as effective from and effective to, and we created a case to see if there is a dbt valid to assigned to that particular record. If there is, it should be false. Yes, you see, if dbt valid to is null, then true. If it is a new record, it should be there shouldn't be any dbt valid 2. So in this case, if dbt valid 2 is null, then assign true, else assign false for is current. So this is where we assign the status for that particular record, whether it is active or inactive. Yeah, that's how we do that. And now let me save this. And where should I save this? Let me organize these folders first. Create a new folder. One for the marks, which have the tables, and another folder for the staging. And yeah, here, let me create another folder, new folder, one for dimension. Dimensions, and another one for facts. Perfect. This should be the dimension table. So it should be named as dim customers dot SQL. Save it. Perfect. And now create another file. New text file. Let's create the accounts one. Most of the part is same as the customers one. So I'm going to copy that. And here, you just need to change the column names. Should be in this staging table right here. I'm going to copy the whole thing up to created at and paste it here. Paste it. Diary created at valid DBT valid from effective to case ID. Perfect, perfect, perfect. Here should be account snapshot. So it should be customers snapshot. Yep, I think that's it. Let me save this as well. In the same position, say dim account dot SQL. Save it. And one more file, one last file in our transformation, which is the fact table. It should be transactions table. Well, this is quite different because it doesn't have a snapshot. Config materialized equals incremental. A key equals transaction ID. P dot transaction ID. T dot account ID. A dot customer ID. T dot amount. T dot related account ID. T dot status. dot transaction time. Current timestamp as load timestamp left join dot count ID equals a dot account ID. Oh, yep. Save this in facts and say fact transaction dot SQL. Perfect. Save it. And I think we're ready now to run the final business ready tables, which will be our goal tables. Okay, now let's head to PowerShell again. To run just the final tables, and we don't want to run the DBT snapshots again. We can, but why to run them? So to just run the final tables, we will be just running the tables that are in these folders that we saved inside the mods. So we're going to run that using dbt run select mods. They should run just the three tables that we just created, and they're all successful, which means we should be able to see the data, which the tables basically, yeah, they're here, and we can see the data, and the data is healthy. Yep, with that, the data transformation is all done. We're all good now, which means we got the business ready data, which is the goal table, goal data in our dimension and fact tables with SCD2 implemented and Snowflake schema. So yeah, well, I said we used SCD2, but let's put that into test if the SCD2 actually works. To find out, go to dbeaver. I already wrote this query before because I tried it multiple times and see if it is working. So here I'm going to change the email for ID number 3 as new 3. Before running this, I'm going to run the faker and generate 50 new records. Or I'm going to generate 40 first. Let me stop this. 40 records first. Hit Control C right after. Yep, stop right there. Now head back to dbeaver and check if the new records are updated. There you go. I'm going to copy this time and paste it here for the created at. Now I'm going to run this. I updated the email and also the created at to the latest date. Right here, the new email is changed. Okay, now I'm going to run the fake generator one more time. That's it. Oh, well, 2 times, that's fine. Now the consumer. Let me see if our new record actually made into Kafka stream. I want to make sure it did. Oh, you know what? It's so hard to find. Well, that's fine. Now we're going to run the DAG. Oh, it is queued already. Okay, let me run that. Trigger that manually. Auto refresh should be turned on. Okay. Okay. Now it is executing. We have to wait until this turns into 125. It did. So we should be able to find our new record. Let me refresh this. I'm gonna run this query to see if our new record made into the raw customer data. I'm gonna search it. I think it's a 3. There you go. So our new data is in our raw table, but let's see if it made into our staging view. For running that, I have to change this, switch this into analytics schema. By the way, just made it. I just queried my staging view, and there you go. Our new email, our old record with the new email is here. Now let's check the snapshot. The snapshot did not capture it whatsoever. I think we have to run the DBT snapshot now. Now let's see. There you go. It does have our new record and also our old record, both of them. And our new record has date DBT valid 2 as null, and our old record got a new date and time, which means if we run another query, to query the data in our dimension customers. But before that, we also have to run dbt run marts, I think. Wait, let me see. dbt run select marts. We run that. The snapshots and the tables have to be, we have to run them to update them. But the views, we don't have to run them to update them. They update automatically. Okay, we run that, and now we will check. There you go. This is how SCD2 works. You see, our the customer ID 3 with the new email, which we just assigned, got the status as true, and the old record got the status as false, and it does have effective 2, and the new one doesn't have effective 2. This is how SCD2 works. And if we add another new email ID for the same customer ID, there will be 3 records displayed, and 2 will be false and 1 will be true in each current column. And this is how SCD is implemented in DBT. So yeah, we use snapshots for that, by the way. Okay. Well, at this point, we're done with everything except for the visualization and CI/CD and DevOps. Yes, and also we need to automate the run for the snapshot and also for the final transformation tables. Like I said, in order to update these snapshots and also the tables, we have to run them over and over again, and a man cannot stand there to run them. Yes, in real world we have to orchestrate it, so we use Airflow to orchestrate them. For that, let's head back to VS Code again, a new file, which is a Python file. I have it already with me right here. So this DAG file is nothing but it has the modules that we need to import, and this is the default args and the DAG configurations. This date and time and schedule interval daily, so it refreshes once in every day. And these are the tasks it should be performing. It runs dbt snapshot, and also it runs dbt run. Okay, now we need to save this in of course docker dags here with the name scd. I'm going to name it snapshots, scd snapshots .py. Save it. But there is one more step we need to do. This DAG file will not execute unless we copy this .dbt inside our banking DBT here. I'll tell you why. Because the dagger file has to execute dbt run, and well, we installed dbt. Remember, we installed dbt in Airflow, but the Airflow composed in this main branch, so it can only access the files inside this one. But to run dbt, we need this .dbt file, which is outside our repository. So we copy that into our repository here and then we run it. So for that, I'm going to copy paste that .dbt file inside our banking DBT because I gave access for banking DBT for that Airflow. So it can now access this DBT file. And one more thing, while you run this, DAG file, you need to edit this dbt project YML because if you have this line macros path of macros, the Dagger file will fail. So you have to take that line out and now save the file, close it. Now this should be it. Now let's run that DAG file and see if it goes well. It takes a few seconds to pop up here. And now we can see the DAG file is up and running SCD2 Snapshots. And let me show you. By the way, this failed one was this failures was not happened today. It was yesterday's, but it somehow saved the data, the log data. Now let's see our DAG file runs. It did run. You see the successful runs. It changed from 2 to 3, I think. Yeah, so it did run, which means our snapshots and also our final tables, which are our business ready tables, will be refreshed every single day automatically with Airflow. So we orchestrated that. Now we're all set with the orchestration as well. Now what's left here is we need to push all this codes and our whole repository into GitHub, and then we need to implement cicd. Yeah, let's do that. But before pushing our whole repository into a GitHub, we need to make sure we don't push the cache data or logs and flood our GitHub. To make sure we don't push any of those files and also our credentials that we saved in .env, we need to configure the .git ignore that we created in our main folder. This one, we need to configure this. So whatever we type in here, whatever the folder or file name we give here, GitHub won't read those files. It just ignores it. Okay. So firstly, we need to, in the first folder, in the GitHub folder, to say catch. I'm going to include that, and let me put a heading for that too. Git Actions. Catch. So there will be catch data produced in this GitHub workflows because of the Git actions that we're going to perform now using CI/CD. So we need to ignore that catch, and also we need to ignore the Docker catch. The Docker catch includes a lot of files like Docker logs and min.io plugins and Postgres, all of them. They're all catch. They all have the data that we don't need to push into GitHub. So we're going to do that. Docker slash min.io and Docker slash plugins. docker slash postgres. Perfect. And now the DBT cache. The DBT cache includes all these files except the models and snapshots. So let's say, okay, banking DBT slash DBT slash analysis slash logs slash. By the way, you don't need to type in all this. You can find this .gitignore file in GitHub itself. You can just copy paste it. You know what? I'm gonna copy paste it right now. I don't need to type this all. Let me do. Yeah, like I said, the dbt cache and then .env file, which will be our. We don't need this right away. Yeah, .env file, which has all our credentials. So it ignores that as well. The PyCache and VS Code cache, dstore compose, docker compose override .oml, all these logs. So all this cache data will not be pushed into GitHub. Now let me save this. Now we're all set. Okay. To push that into GitHub, we need to be in our main repository, and here we need to type in git init. We need to initialize the git. Initialized empty git repository, which means it should be we should be able to see this folder created when we initialized. Okay, now we initialized git, then we do git add dot represents to add everything that we did till now, including it includes everything from A to Z, the whole project, all the codes and all the changes that we made will be added to GitHub. Okay, run that. All right, that is fine. Now commit the changes using git commit and the message attached to that saying for step 1 initial repository. Not sure if I spelled the repository spelling right, but you know what, I'm gonna commit that changes. Okay, it shows all the files and folders that we committing. Then we need to specify the branch that we're going to commit, which will be main because we haven't created any other branch yet. So git remote add origin. Here we need to put the link by creating a repository in GitHub. Let me open GitHub real quick. Let me open my GitHub and add a new repository and name it banking. No. modern data stack. Banking modern data stack. Perfect. Create repository. Now we have this. Copy the whole link of your repository and paste it here right next to the origin. And at the end, you need to type in .git and now hit enter. Now it should be connected. Now push the changes, push the commits that you did. Origin main. Perfect. Now when you refresh this page, you should be able to see all the files that we just created. Now we have everything inside here. And by the way, if you take a close look, you don't find any .env files anywhere in any of the folders. Even if it is still, if they are still there in our local repository, the .env files, you cannot find them in here because we use them, we specified them in .git ignore. So those files got ignored and no credentials are uploaded to GitHub, which is secure. And now we have all the repositories set in the GitHub. Our next step should be implementing cicd. For the cicd, I have the codes with me. Let me just copy those codes real quick. Right here, let me just, this is the CI code. Let me head to VS Code again, a new file, new text file, paste it. Now I'm going to tell you what we're doing here, okay? And I will also try to explain what CI is. CI is nothing but the continuous, CI stands for continuous integration. It is nothing but a security check before entering into the main branch. Let's say it is like, it is like a screening check. Whenever you do any changes to the existing code or you post any new code inside your main repository, before it gets into the main repository or before the code reaches into the main repository, this CI will be executed and see if there is any errors using the tests that we will be specified in here. And if any of the test, if the code fails to comply any of the tests and CI gets failed, the changes will not be published to the main branch. Okay, in this CI code, we are running Ubuntu latest because in Git Actions, we're running this CI in Git Actions. So it creates a virtual environment on cloud by itself and installs a Postgres with the port number and all the things. And then installs the requirements.txt that we already created and also installs DBT Snowflake again. It runs linters. Linters is basically, it checks the syntaxes, checks if there is any syntaxes or formatting errors in the code. But if there are any technical errors, it will not, it will still pass the linters check. So linters only checks the syntaxes. If the syntax is correct, it will just pass the linters test and then it goes to unit test. Unit test will be, we haven't created any particular unit test for the Python here, but we can in future I created some DBT tests though. Here I specified everything. I gave access to the Snowflake. I haven't, but this is where we are going to use our account credentials. These credentials will be given inside Git secrets, and from there it will be retrieved into the CI code, and it can get access to the Snowflake. And yeah, this whole block is about configuration, and here DBT deps is nothing but a linter test for Python, and we have DBT deps for DBT codes. So it checks the syntaxes just like that, and even if it has error, if the syntax is correct, it will just pass the first test, which is DBT deps, and then it goes to DBT compile. Here is where our test will be run, and here it checks if the DBT is actually running. So this is the second test. If any of this test fails, the newly coming code, the newly entering code or the newly changed code will not be entered into the main branch, and it will be taken out, and the error pops up to us. Basically includes two branches, main and dev. Both of them can access to that. If any of these two branches sends a new file or updated file into GitHub, Git Actions executes CI and checks these tests. Okay, I hope you get it, but well, I tried to explain it clearly, but yeah. Okay, let me save this first in Git Actions, .github in workflows, and name it ci.yml. Save it, and let's do the same for CD. Okay, let me create a new text file. This is a CD code. Well, CI is for checking, for the testing, and CD is for deploying. Whenever a code enters into the GitHub, it automatically deploys using this code, and we specify what to deploy and how to deploy. For now, we don't have access to the orchestrator because our Airflow is running locally on our host machine, so we are not able to deploy that using CD YML. But if it is running by hosted by a cloud server, we will be able to run that orchestrator using CD. But in our case, unfortunately, we don't have that. But we will be doing that in future projects in our channel. But for now, we don't have it. By the way, the deployment access is only given to main branch and not the developer branch. The developer only can have access to continuous integration, but continuous development is only accessed by main branch. And it deploys the DBT run DBT test, like as in CI. So yeah, this continuous integration and this continuous development. Let's save this file as well. cd.yml. Save it. Now we need to, we haven't hard coded any of these secrets as well, and we are passing it into GitHub. But GitHub needs to get those secrets from somewhere, right? To run these YML files. For that, GitHub offers a feature where we can save our, let's say, secrets. Trying to find right here, this one, banking modern data stack, and here head to settings, and under secrets and variables, click on Actions, and repository setting, click on New Repository Setting. Here we are going to upload the settings here. Firstly, we need let's upload the Snowflake account. Which is this one right here. Add secret and do the same with another one. Snowflake's user. Same for the password. I'm gonna pause it, okay? I'm gonna type the password and then unpause. Okay, added that, and now Snowflake warehouse. Paste it. In the warehouse name, compute WH. Add secret. Okay, I think I left something. That is Postgres user and Postgres password. I think the credentials for this is, forgot the credentials. I think it should be Postgres. Yeah, it is Postgres. Okay, Postgres. And same for Postgres password. Also Postgres. Add secret. Perfect. Now open PowerShell. Now we are going to create a branch for developer using git checkout -b dev. We're creating a branch here. Switched to a new branch, developer. To check it, just click git branch, and you see the star is indicating the active branch, which is developer, and we are not on main branch anymore. So here, basically a developer branch is a playground. You can do anything here, and if you think a program or a file is finalized, you can just push it to the main branch. You can just push it to GitHub, and whenever you push it to GitHub, the CI will execute and checks if there is any errors, and if that passes, someone from main branch should accept your pull request. You have to raise a pull request, and someone from main branch should accept your pull request, and they execute CD, and then your change will be made in the main repository. Okay, now we're in developer branch. here to git add dot github slash workflows slash ci.yml do git commit -m with a message saying sure add ci workflow. One file is changed. Now git push origin dev. Oh, I said div, sorry. I typed in wrong. Git push origin dev. Okay, now if we head to GitHub, you should see dev had recent pushes 2 seconds ago. And if we switch to actions here, you will be able to see the CI right here working and testing the new change. If any of these steps fail, any of these tests fail, the new change will not be deployed. New change will not be integrated with the main branch. It takes few seconds, and yeah. So the linters is successfully completed, which means the syntax is all correct. And now the DBT compile, that is also done. Yep. When everything is successful, you will see this green check mark right next to the tests, which means it is successfully deployed. Successfully ran the test. Now, here, from the main branch should approve this change using this one, compare and pull request. Click on that and say create pull request. You can add description or title. It's completely up to you. When you try to integrate it with the main branch, it runs the CI again, because we defined it when we write the CI via mail. We said it should also be done when someone from main branch pushes it to, pull request pulls to, sorry, I think I messed it up. We specified here, even it's a main branch, even he does any changes, the CI via mail should be executed again. So that is what happening here. Even someone from main branch is doing this, it still doesn't integrate the change directly to the main repository. It still runs the CI and checks it. And yes, now we click on merge pull request and put our message here, confirm merge. Now it is merged with the main repository. Yep, that is done. We can find our CI/YML here. Now let's push the CD as well. To push the CD, you cannot push it from developer environment. You have to switch that to main branch. To switch that to main branch, we go checkout, git checkout main. Now we're switched to main branch. But here's the thing, because we committed a few changes in our main branch from our GitHub web UI, we need to do a git pull first to make it in pace with the Git UI, Git online UI. Okay, now from here we can add that file, add the CD file. Let me just copy this, say cd yml git push, no, git commit -m cd initial, run it, one file changed. Now git push origin main. Now we are pushing directly to the main branch. We don't need to approve, we don't need to do the pull request here. When we run this, the changes goes directly merges to the main repository. Now when we switch to actions, we should be able to see cd as well. Now both of them are running. There you go. Oh, don't worry about the cd initial, because this is what I committed that with, the message that I committed with. You see, cd initial. So yeah, so the CI is running and also the CD is running. So whatever pushed by main branch will go through the test, a few tests done by CI, and also the CD will automatically deploy the changes to the main repository. I think I forgot to explain the CD. I think maybe I did. CD basically, for now, CD just deploys the changes in DBT code into directly into the Snowflake. In future, we can change the orchestration tool and make it hosted by cloud, and we can also add that orchestration into continuous deployment. So whenever a new change is done in our main repository, the continuous deployment makes sure that particular change is out there in the project as well. There you go. The CD is completed and the CI is also completed, which means now our project is we successfully implemented CI/CD in our project and also DevOps. With that being said, 90% of the project is completed. The only thing left here is data visualization part, which is so easy. Okay, let's do that. We're almost done. To do that, open Power BI desktop. If you don't have one, if you don't have it on your PC, try to download it from a browser. It is free, or you can also download it from Microsoft Store. Okay, this is the home page. To connect to Snowflake to get the business ready data, you have to click on get data from other sources. Here, click on search for Snowflake right here, or you can switch to databases. No, sorry. Okay, right here, the Snowflake. Click on connect, and for the server, again you have to go to the session details and copy this particular thing. I think you have to copy the whole thing for this. It should also include .snowflakecomputing.com and paste it here, and warehouse will be our compute WH. Okay, unable to connect. We encountered an error. We're trying to connect details, incorrect username or password. I changed my password. I forgot that. I'm gonna cancel that. Go back to home. Options and settings. Let me pause it. This is what happened. I already logged in, but I changed my password for the Snowflake recently. But the Power BI saved my old password. That's what happened. Now let's go back. File. Get data. Search for Snowflake. Again, paste it here. Copy that. Paste it here. Click OK. Now it asks for username and password. You have to put in your username and password here. Click connect. Now we will be able to see our databases in the Snowflake, and our database is banking, and we need the final business ready data to be imported, which is dimension accounts, dimension customers, and fact transactions. Load them. Here, like I said before, we are going to use direct query to make the data live and not static. There you go. We got the data now. Okay. Before going further, switch to model view. Connect these tables accordingly. Well, it connects in Snowflake schema, which is the account ID from accounts should be connected to this one. Is that how it should be? Let me check. Models, maths, dimensions, facts. Not customer ID. So it is connected with account ID and also customer ID. Okay. Cancel. So account ID in accounts is equal to, wait, I forgot that again. Let me see that. Is equal to account ID here. Oh, okay. That makes sense. Yep. Should be many to many relationship. No, one to many. And the cross filter should be both save. And the same thing for customers. The customer ID should be matched with customer ID on accounts. And the relation should be many to many. Perfect. Now head back to the visuals pane. Well, I just asked ChatGPT to suggest me a few KPIs and charts that I can create with the data that I have. So let's create a basic and a pretty good looking dashboard. Well, it says I can include KPIs for total customers, which is a great thing. So I'm going to click on card and total customers, should be customer ID. Count of distinct, perfect. So 198 distinct customers, and another KPI for account, number of accounts. So if we're going to include that and say count of distinct, 400 distinct accounts, and another KPI, count of transactions, total transactions. Well, that's a good KPI too. For that, which one is the transaction ID? Is transaction type. This is transaction ID. Count distinct. Okay. Sum of amount doesn't make any sense to capture. Well, we can capture average balance. That's a good KPI to capture. That should be in accounts, and balance should be average. Okay, perfect. We have 4 KPIs. Let's create a few charts. Okay, it shows trend, line chart, transaction time, count of transaction ID. Yeah, perfect. Transaction time. Instead of line chart, let's go with the area chart. Stacked area chart, area chart, this area chart. Oh, this is the area chart. Transaction time, this one, and count of transaction ID should be on y-axis. Count distinct. Oh, it doesn't make any sense because we just created all these records at the same time, so it just combined compressed at one timestamp. So I guess we can't use that. Well, let's choose a different chart. Let's choose this bar chart. Access customer ID or first last name, sum of amount, top 10 customers by transaction. Perfect. What can we do for that? We have to click on column chart and choose customers as y-axis and sum of amount. Perfect. Let me just see. Okay, let me do that again. For the customer ID and for the amount, sum of the amount. Let me filter the customer ID with top 10 and drag this amount field here, apply filter. So we're just selecting top 10 customers Now we create the bar chart. I think I have to take this out. Exclude. No. I don't know why we are getting blank. Okay. Let's just exclude the blank, I guess. Okay, this is the top 10 customers with based on the sum of amount, and yeah, another chart can be donut chart for transaction type and count of transaction ID. Okay, let's do that. This is the transaction type, and count. Perfect. Oh, it is so close. Then let's just do the amount in the value instead. Oh, that is also so close. Okay, that doesn't matter then. I'm gonna leave it like that. And one more chart. A histogram. Let's just create another bar chart. Copy paste it. And this time, instead of customers, let's choose accounts. And here, take this filter out. Instead, let's filter by accounts with amount as by and top 10. Apply filter. Perfect. Fit that there and fit here. Format, details. No, I think that's the legends. Yeah, got the legends. Organize them real quick. We're just going to create a basic dashboard, like I said. I'm not going to focus more on the dashboard because this project is basically on banking. The dashboards are not a main part of banking, as far as I know. So we're just going to make it faster and quicker with the dashboard. This average balance, let's format it with here and say currency. So the dollar symbol adds right next to it, and also the decimal places, increase it to 2. Perfect. Now here, add title, header icons. I don't think it's header icons. It should be category label, turn off, title, and say average balance. Perfect. Align it to center. Do the same thing with this. Title on. Say total customers. Align it to center. Category level off. The same thing. Category level off. Total transactions. Align it to center. Title. Total accounts. I forgot to align it. Align it to center and category level off. Okay. This is just fine, I think. Properties. Perfect. Let's just copy this for everything so that the size for everything is equal. And also the height. Perfect. For the donut chart, let me add another KPI card in the center. And sum of amount. Choose amount. Set. Effects. Turn off the background. Data format. Currency. It's fine, and call out value. Just to fit it inside the donut chart. Like that. Perfect. Let me save this real quick. Banking. Dashboard. Inside. I'll save it here for now. Save it. To make it look good, let's insert this shape. Make it fit the KPI. And change the color. Style,
color, this gray. Maybe this one should fit perfect. No border. Maybe shadow. Okay. Remove the background for this. Copy paste. Copy paste. Paste. Shit. Remove the background. And also content that fits this. That's perfect. But I think that looks good, the formatting, but yeah, we can do a few more modifications. Just change the color of these bars. What if it is this color. Maybe blue. It still looks like a default color. Yeah, we'll do purple. Purple for this one too. And for this color, right wall, withdraw. Deposit, but we're going to do it a little bit lighter. And for transfer, more lighter than that. Good. And for the title, white. Start with the KPIs. Turn everything into white. Okay. Labels. Same thing for this. I don't know if I'm making it look good or making it worse, but I'm trying my best to make it faster because we're not focusing on data visualization anymore. We're not focusing on data visualization in this project. Our main focus will be in data engineering, so I want to make it faster and quicker. Okay, I think that's a pretty decent dashboard. You might not like it, but still, it is a pretty decent one. For the last touch, I'm gonna go account by ID to make it not look like a computer generated title. The same thing for this. Perfect. That's it. Now, if we take a look at our data pipeline, we're done with everything from A to Z. We created our database, which is our Postgres database that we created, which is SQL database. basically. And then all the changes that are done in the database, insert, update, or delete, all those changes are captured using Kafka plus Debezium, which is the CDC data streaming stage. And then that stream data is taken out and pushed into and stored into our S3 bucket, and then it is pulled out and stored into Snowflake's bronze tier table and cleaned, and then stored into silver tier table, and then stored into bronze tier table. And this whole data processing is done by DBT and Snowflake as data warehouse, and orchestrated the whole process with Apache Airflow. And then we implemented cicd, we implemented DevOps, and then the business ready data is then connected to Power BI, and then there we created a data visualization, which is our dashboard. And yes, this is the end of our project Modern Data Pipeline. Well, we included most of the modern data stack tools and also implemented enterprise best practices like SCD2 and star schema, CI/CD, DevOps, most of them. I think I covered most of those topics. And with that being said, I will be back with a new project, new video. Until then, take care.